Welcome to the second video on random variables. This one's about means and variances of random variables. And the mean is also referred to as the expected value. And that's because it's the value you're expected to get if you do a large amount of samples. Let's start off with our probability distribution that we have here. We have our random variable and the values it can take on, and then the probability of that random variable, so the p of x here. And if we want the mean of that, you can think of it as a weighted average. We're taking each random variable value and multiplying it by its probability, then we are adding it to the next random variable multiplied by its probability until we get through all the random variable values. And random variable values are, the mean is denoted by mu with a subscript of the random variable. So let's say x or y. And if you remember, random variables are capital letters. The formula you will see on the formula sheet is the one that's listed there. The capital sigma, meaning summation, and you're going to add the probability and the random variable multiplied together. You're going to add all those terms together. And this is the expected value in the long run. Now the variance, which is just standard deviation squared, is essentially figured out the same way as standard deviation and variance in the beginning of the year, where it's the x value minus the mean, all squared divided by n minus 1. Here, the probability is the fraction, and it's going to weight instead of adding everything and then dividing by n minus 1. Here we're going to multiply by the probability as we go. So we're going to take the random variable value, subtract the mean and square it, and then multiply by the probability. And then we're going to do that for each term, and that's going to give us our variance. Now, if we want a standard deviation, you're just going to square root that. So let's do an example. Pause the video and try to calculate the mean or the expected value, same thing, and the variance. And if you want, you can calculate the standard deviation. Okay, here are the answers. So I have the x value and the probability. I multiplied these together and then added all the values to get the expected value or mean of the random variable of 1.1. This squared should be outside the parentheses. So then I took the x value, 0, minus the mean, squared it, times the probability. Did that for each x value here. Then you add these, and you should have gotten 0.89. Now, if you did the standard deviation, that was 0.9434. Now, you can do this with your calculator lists. Some ways it can be a little harder for such a small sample size to bother doing that. And you won't be asked for a huge list of numbers. You won't be like 20 numbers. Find the standard deviation. It'll be like, 4 numbers like this one. All right, then we have the law of large numbers, and that is in repeated samples, larger and larger, and you get more and more samples, you're going to get to the expected value. You're going to get closer and closer to that expected value. So for example, if I drew more and more samples of women 18 to 24 and measured their heights, I'd get closer and closer to the actual mean. So here is a simulation. So let's suppose that women's height, the mean was this 64.5, this dotted line. So the first, as I start to take a few samples, so number of observations here, you can see I might get some rogue small samples, small numbers there. But as I get more and more observations, any low numbers or if I had a high number up here, those get averaged out with all the samples that are close to the mean, and by way out here on the 10,000s, any weird sample is still gonna, it's not gonna have that much of an impact, and you'll be close to the mean. So who uses the law of large numbers? Well, casinos is the most obvious one. And that's, if you know anything about casinos, all the games except for blackjack, poker's a totally different thing. Uh, their probabilities are in the house favor. Now they might only be by a little bit, but the casino is playing with customers playing these games millions and millions and millions of times. You're only playing, let's say, 100 games. So you might win once in a while, but in the long run, out of all these millions of people playing, the house is always going to win because there might be a few big payouts, but there's all these other people losing money. So it averages out to be in the casino's favor. Insurance companies, they also use this to figure out how much they should have people pay in premiums. And if you're an actuarial math major, this is something a lot of people do is they work for insurance companies and the modeling of the probabilities and who expected values and who should pay what. All right, so then the question becomes, how large is large? And that depends on the variability of the event you're talking about. If you have a highly variable random variable, then you're going to need larger samples. But if you have only a slightly variable random variable, you don't need as many because it's more consistent and you won't be getting outliers in your samples. Now, law of small numbers, there isn't one, but people think they're using the law of large numbers when they're usually actually using small numbers. And the most common one of this is in sporting events where sportscasters be like, well, he's due for a home run because 1 out of 20 at bats, he gets a home run. And it's his 25th at bat. However, that's still a short run, 25. That 1 out of 20 is through his whole career. So he really needs more at bats. Nobody's ever do a home run or do, on base. Now, a less sports related one is this experiment has been done. If you have somebody write down 10 heads and tails, they will most likely not write a string longer than 3 because our brains, for randomness, don't think like we can have 5 heads in a row. Whereas a run of 3 or more in a group of 10 is actually over 50%. So, our brains though don't think that that's a possibility. So we're not that great at probability mentally. All right, back to formulas. So we have rules for the expected values. So let's say we had a random variable that had some values and probabilities. Sorry about that. I'll just make these up, 5.2 and 0.3. All right, so if this was in, let's say, Celsius, and we wanted to convert all our random variables to Fahrenheit, we would have to multiply by 9/5 and then add 32. So you'd have to take all the random variables, multiply by 9/5, add 32. But if we already had the mean, we could just take the mean. I'll do mean in Fahrenheit. of the mean in Celsius and add 32. So we wouldn't have to do it to each variable, each random variable value. We could do it just to the mean. Then if we had two random variables and we had the means of each, and we wanted the mean of the random variable, if we added all the values together, we can just take the means and add them together. All right. So let's take an example. We have Linda, and she's also selling SUVs now. Very exciting. And I want you to find the mean of the random variable of the trucks for a second. Should be easy, so pause for a second. Okay, so if you did it right, we already did the cars, and the expected SUVs is 0.7. So now let's take an example. If she earns commission on her cars and SUVs, and she expects to earn $350 on each car and $400 on each SUV, we want to know what's her expected earnings. So we're going to combine two values, two of our rules. We're going to take our how many expected cars and how many expected SUVs, multiply them by that constant for each, the 350 for cars, 400 for SUVs, and then we can add them together, and she's expected to make $665. All right, then finally we have rules for variances. And the first rule is if you're multiplying all the x values by a constant, then you just multiply the standard deviation by that same constant. Or if you are doing the variance, you just square the constant and multiply by the variance. So like if I had sigma sub x and I multiplied all the random variables by 2, I could just multiply the standard deviation by 2. Then if I had two random variables that I want to add together, like the cars and SUVs, if I had those random variables, I can just add their variances. If I'm subtracting, though, I also add their variance. So it doesn't matter if you're adding or subtracting, you're still only adding the variances. And you can't do anything to standard deviation. You have to do that at the end because of order of operations. And the minus is because with the spread, you're only shifting if you're adding or subtracting, it's only shifting. The difference between them is still the same, so the variance doesn't change. Mathematically, if you want to think about it, if you're squaring a negative, it's still a positive. We will do an example in class to make this a little more concrete for you. But for now, just the rule, whether you're adding or subtracting the random variables, you're going to add the variances. All right, so that is the end of the video, and we will do some practice to hopefully clear this up in class. Thank you.